Lesson 7, Advanced Interaction Techniques, T formulae. Excuse me. Example 1, evaluate the integral between pi upon 3 and 0 of 1 over 1 plus sine x dx. Now in this case here we're going to use the T formula, and as T stands for the tan of x over 2. Right, and if we differentiate this we get dt dx is equal to 1/2 sec squared x over 2. Now we need to put that in terms of t, and to do that we'll draw a little diagram here. I'll do it down here. Okay, that's my x over 2 there, the t there, and a 1 there, and that'll be the square root of 1 plus t squared. Now the sec of that is going to be the square root of 1 plus t squared, but we're squaring it, so dt dx equals 1 plus t squared over 2. So you can see that dx dt equals 2 over 1 plus t squared, which gives me the result that dx equals 2 dt over 1 plus t squared. Right. Now, we need to find out what sine x is, but before we do that, we'll just get these limits out of the way. It's the limits. Now, when x equals pi upon 3, t equals the tan of pi upon 6, which is 1 on root 3. And when x equals 0, t also will equal 0, because the tan of 0 is 0. Right, now all remains now is to get that sine x. Now sine x is equal to 2 sine x over 2 cos x over 2. And that's equal to 2. Now sine x over 2 from here is going to be t over square root of 1 plus t squared. And cos x on 2 is going to be 1 over the square root of 1 plus t squared. So that means that sine x equals 2 over 1 plus t squared. If you like, you can remember these formulae, but they're quite easy to derive. Now we've got that all set up, we can now evaluate the integral. So I equals the integral between 1 on root 3 and 0 of 1 over 1 plus 2t over 1 plus t squared times 2 dt over 1 plus t squared. That's equal to integral 1 on root 3, 0, 2 dt over, now these ones will cancel out, but this will be 1 plus t squared plus 2t. So 1 plus t squared plus 2t is a perfect square, which is 1 plus t all squared, and that equals 1 on root 3, 0, 2 outside, 1 plus t, so minus 2 dt, which is 2 bracket 1 plus t, increase it by 1, minus 1, on minus 1, I'll put the minus at the front, between 1 on root 3 and 0. Switching it around, it's 2 outside of 1 over 1 plus t, between 0 and 1 on root 3, which equals 2 bracket, now put the 0 in, which is 1, minus 1 over 1 plus 1 on root 3, and that is 1 minus, so this will be root 3 over root 3 plus 1. Okay, rationalising the denominator. Or we could put over a common denominator first, I guess, because that becomes root 3 plus 1 minus root 3. So this would be 1 over root 3 plus 1. Now we can rationalise it. And that becomes 2 outside of root 3 minus 1 over 2. And the answer is simply root 3 minus 1. Example 2. Find the integral of 1 over sine x minus cos x dx using the t formula. Slightly more involved, this one. So we know that t equals tan x over 2. Just drawing the diagram. T1 x on 2 square root of 1 plus t squared. Now we know from previously that sine x was equal to 2t of 1 plus t squared. Now cos x equals 2 cos squared x over 2 minus 1, which is, now cos of x over 2 is this 1 over the square root. So when we square it, we get 1 over 1 plus t squared. So it becomes 2 over 1 plus t squared minus 1, which is 2 minus 1 minus t squared over 1 plus t squared, which is 1 minus t squared over 1 plus t squared. Now we know previously that the x was equal to 2 over 1 plus t squared dt. Now this is indefinite, so we don't have to worry about the limits. So the integral is equal to 1 over 2t over 1 plus t squared minus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt. So that becomes 2 over, now these will all cancel out, and you'll simply get 2t minus 1 plus t squared dt, which is 2 outside of 1 over t squared plus 2t minus 1 dt. Now this isn't a perfect square, so what we're going to do now is we'll complete the square and write this as 1 over t squared plus 2t plus 1 minus 2 dt, and that equals 1 over t plus 1 all squared minus, and write this as the square root of 2 all squared. Now that's now the difference of two squares, so we can write that as 1 over t plus 1 plus root 2, extend that a little bit, t plus 1 minus root 2. Now this is a partial fraction thing, but it's a fairly easy one to do without going through all that bother. I write that as 1 over t plus 1 plus root 2 minus, actually I'll change that again, I'll make it, you don't have to do it this way, but it just makes life a little bit easier. I'll write that as t plus 1 minus root 2, and this one is here 1 over t plus 1 plus root 2. Because what's going to happen, we take that across to this side and that one to that side, you would have got rid of these t's and the 1's, but you would have been left with a root 2 here and a plus root 2, which would be 2 root 2. So what I need to do is just to put a 2 root 2 underneath that. And that's right. So it's 1 on root 2, integral of all this. T. And of course that is simply 1 on root 2, root 2. And this will be log of this one minus log of that one. So that's going to be the log of t plus 1 plus root 2 over t plus 1. So t plus 1 minus root 2. Sorry. Should have drawn this a little bit bigger, hadn't I? Minus there. Over plus here. Plus some constant. We should put some absolute value signs around that. Where t equals 10x on 2.